So we're finishing up our example from last time, talking about kids riding the bus to school. So we looked at our picture and said that the school was at the coordinates 1, -2. So that means we'll want a circle with its center at 1, -2. And then the radius will need to be 2 because we're looking who lives 2 miles from the school. So if we write our equation, we should get x minus 1 squared, y minus -2 squared is equal to 2 squared, which means when we simplify it a little bit, we'll get x minus 1 squared plus y plus 2 squared should equal 4. So we'll use our inequality so that we want to look at the values greater than 4 because we're looking outside of our circle. So we can graph this on our circle here. So what do we have? 1, -2 with a radius of 2. So our center is here. Look at a radius of 2, 2, 2, 2. So this is our circle. So we're trying to determine which points are outside of that circle. So point C, point B, and point A are all outside of the circle. Unfortunately, E lies on the circle, so it's not going to count. And then D is inside the circle, so it won't count either. So again, the points outside the circle are the ones that count. So that means the students at A, B, and C are eligible to ride the bus. So in part B, how did we know that point E wasn't outside the circle? Well, we can see that it lies on the circle. But if you're ever in doubt, obviously I have a hard time drawing circles. If you're ever unsure whether a point lies within or without of your circle, you can use the distance formula or Pythagorean theorem. So when in doubt, use Pythagorean theorem, the distance formula, to double check. So we need to write an inequality represents the situation and then draw a circle to solve the problem. So Sasha delivers newspapers to subscribers that live within a 4-block radius of her house. So that means, again, we're looking inside the circle. So her house is located at the point 0, -1. And A, B, C, D, E represent the houses of some of the newspapers. So we have to see which ones she will deliver to. So this means our center is at 0, -1. And our radius is going to be 4. So when we write our equation, we'll get x minus 0 squared plus y plus 1 squared is equal to 16 because that's 4 squared. But since we're looking within a 4-block radius, we don't want to be equal. We want to pick the values less than 16 because that means the distance from our center to our point is less than that, so they would have a smaller radius, so they'd lie within the circle. So our circle is centered at Sasha with a radius of 4. We will move 4 up, 1, 2, 3, 1, 2, 3, 4 up to here. 1, 2, 3, 4. Whoa, not that one. 4 to the right of Sasha. 4, 1, 2, 3, 4 down. And 1, 2, 3, 4 left to draw our circle. So based on this, looks like B, D, and E all will lie inside of our circle. So the process of deriving the equation of a circle given its center and its radius, it comes from knowing the center and the distance, which is the radius, to use the distance formula and create our equation, x minus h squared plus y minus k squared equals r squared. So what must we do with our equation in order to graph it? We have to complete the square twice. So what do the inequalities where we're less than r squared and greater than r squared represent? Remember, if we're less than, that means we're looking for the values in the circle. And if we're greater than, we're looking at the values outside the circle. So then what information must we know or determine in order to write an equation of a circle in standard form? Well, we need to know the center and the radius. But all you really need are 2 points on the circle. If you know 2 points on the circle, you can use the distance formula to find the diameter, which then you would take half of to find the radius. And if you have the 2 points, you know that the midpoint then would be your center. So while our equation calls for us to know the center and the radius, if you just know 2 points on the circle, you actually can find the equation for a circle.